continuing our practice with the context of the situation. So, can we look at a graph and say, okay, here's what's going on with the real world situation. Here's what's happening with the model that this graph is trying to talk about. So I want to go through just a few more examples with you guys. Um, there's two things we really got to consider when we're looking at it. And it's the same two things we've been dealing with this whole time with linear equations, and that is the starting value and the growth. Starting value, we know we can find that as the y-intercept on the graph. The growth, we know we can find as the slope on the graph, and it's going to be the rate of change in this case. A slope is how things are changing. So we're going to consider these two things here. Okay, what's our starting value? Well, first off, this is Josh's car trip. And anytime we're looking at a graph, we want to read the title first so we know what the heck it's talking about. And then we'll read the two labels, okay, time in hours and also the number of miles from Josh's home. So we're talking about this is how far away he is from home, and this is the time in hours. So this is Josh's car trip, and it looks like he's far away from home. This is miles from home. So we got a starting value here of 160 miles. What's that mean? 160 miles from home. So that's his starting value. Okay, well, now we're looking at the growth. We need to find another point. Well, how about right here? That's a nice little point that touches exactly. So let's go this way and this way. So my change in y went from 160 to 120. Well, that was a loss of 40, right? That's a loss of 40 from 160 to 120. And my change in x is 1. Well, let's give these some units here, because this is time in hours. So that was 1 hour. And this is miles from home. So that's in miles, 40 miles. The slope in this case, change in y over change in x, is negative 40 miles over 1 hour. So when we divide that, we get negative 40 and then miles per hour. I'll just say MPH, negative 40 miles per hour. So what's the context of this situation? An answer to this, if I said, what's the context, what's happening here, you would say, well, he's starting 160 miles from home, and he's heading towards home at 40 miles an hour. Yeah, it says negative, but that's because we're losing value from miles from home. It's just saying it's more of a direction. The negative is more of a direction, right? We're losing miles from home, which means he's heading towards home. So you can say that in context. That's what it means. Yeah, it says negative 40, but what it means is I'm heading 40 miles an hour towards home. So starting at 160 miles from home, he's driving 40 miles an hour towards home. Okay, so something similar here. We don't have a title. So let's look at these. We got time in weeks here along the x-axis. And then we've got a beard length in millimeters. So this looks like a graph of beard length over time, right? Okay, well, we've got two things. We got a starting value. It's right here. The y-intercept is 10 millimeters. And then let's find the slope. Let's find the next, looks like the next point right here. That means my change in y is from 10 to 35. You can see each one of these lines here. 10 to 35, that was plus 25. Well, plus 25 what? Millimeters. We're going to use that, plus 25 millimeters. And then from 0 to 10, change in x was 10 weeks. So the slope then is 25 millimeters in 10 weeks. So when we divide that, that's 2.5 millimeters per week. And I know I've told you guys before that I like fractions. So if you want to keep it in that, it's millimeters per week. But that's what's going on. So your final answer would be his beard, did he come out of the womb? So we gotta understand this here. A starting value of a 10 millimeter beard. Was he some baby come out? He's bald baby, but he's got a 10 millimeter beard on. No, that's not what's going on. This is clearly just when he started measuring. So sometimes you have to take a little context, right? The context to take your contextual clues. I'm sure you talked about that in English class, right? It's not always so obvious what's going on. You got to think about it, take some clues in. Obviously, he doesn't have a 10 millimeter beard as a baby, so that's not where he started. Um, but this is when he started measuring it. So you'd say something like, um, his beard was already 10 millimeters long when he started measuring. And then from there, he grew 2.5 millimeters per week. The beard grew 2.5 millimeters per week. So these are the two things you want to talk about: the starting value and the growth. So you're going to find the starting value here in the y-intercept. Then you need to find the slope, and that's going to tell you how it grows. Now consider, our slope is change in y divided by change in x, right? Change in y divided by change in x. So it's when we're talking about units here, right? This one's in miles per hour, and this one's in millimeters per week. So it's going to be y divided by x, just like the slope is, right? Millimeters per week, miles per hour. So we're thinking y divided by x. The units are going to follow that as well. So negative 40 miles per 1 hour, negative 40 miles per hour, and 25 millimeters per 10 weeks is 2.5 millimeters per week. It's going to be y divided by x, just like the slope. The units are going to be the same way. So when you do the rest of these, those are the things you're going to be finding. Starting value, slope. Also include the units for what the slope is or what the growth is, what the change is. And when you explain things, talk about starting, talk about how it's changing.